Okay, so the problem we have here is 10.15, and it's an additional example problem that Professor Mayer has given to us from the book. And so in this problem, we don't have a friction, we're going to ignore it. But the wheel is going to be rotating, but it's going to be stationary along the horizontal axis at the center of the wheel. And so we have a constant tangential force, which is equal to 80 newtons, and it's going to be applied to the rim of the wheel. And so since it includes a tangential force, we know that we're going to include torque. And torque is a twisting or turning of a force. And so in torque, you usually have a pivot point, which is right here. And then you're going to have a tangential force. And the tangential force is going to be perpendicular to the pivot point. And the pivot point is pretty much the center point of any rotational system. And so for our problem, it's the center of the wheel. And so this problem also said that our radius is going to be 0.12 meters, and it's initially going to start from rest, and after that, at 2 seconds, or after 2 seconds, the speed is going to be 12 revolutions per second. And it wants to know the inertia after 2 seconds. And so what we're going to do is we're going to list what we already know. We know that our initial velocity or initial angular velocity is going to be 0 because it's starting from rest. And we know that after 2 seconds it's going to be 12 rev per second. And so we need to convert the rev per second into radiances so that it can follow the SI unit. So it's going to be 12 rev over 1 second over 2 pi radians over 1 revolution. And so the revolutions are going to cancel each other, and you're going to be left with 24 pi radians per second. And so we have that. And so we're going to find our torque, which, because I mentioned earlier that this problem includes torque. So we're going to have torque is equal to the force, or the tangential force, times the radius. The tangential force is going to be 80. The radius is going to be 0.12 meters. And so the torque is going to be 9.6 newtons times the meters. And so our angular acceleration is going to be similar to our velocity acceleration. Like, it's going to be the final velocity, or the final angular velocity, minus the initial over the time. So it's going to be 24 pi minus 0 over 2 seconds. So it's going to be pretty much a 12 pi. And so we have an equation that pretty much ties in everything, which is pretty much torque is equal to inertia times angular acceleration. And so we can do algebra to like make everything equal to torque, equal to inertia. So you pretty much divide by angular acceleration, and you're going to be left with inertia is equal to torque over angular acceleration, which is pretty much I is equal to 9.6 over 12 pi, which is pretty much 0.255 kilograms times meters squared. And so this is the answer to our problems.